Hello everyone, I am Samir Velankar and I welcome all of you to this next video on linked list data structure. In this video, we will see how to create a circular linked list using singly linked list. Now actually circular linked list, as we learned in the fundamentals, will have node in which in every node there will be some data and a next pointer. Data and a next pointer, and assume that this is the last node added, then the next pointer of the last node will point back to the first node. And of course, we will have a first pointer as usual pointing to the very first node, that is 10. Also, we will have one more pointer last, which will always point to last node. Now, advantage of having a last pointer, especially for circular linked list, is that this relation last to first, this relation can be easily maintained if you have one dedicated pointer at the last node. See, otherwise, there is no use of last. Absolutely. Because keeping a pointer at last node is of no use in a singly linked list, because you all know that you cannot traverse backwards in a singly linked list. So what's the sense? I mean, you can only traverse to the next node, isn't it? But using a last pointer can quickly help us in maintaining the relation from last to first. By the way, after describing all this, you might have understood that the program for singly linked list is going to be changed only a bit. By bit, what I mean is only one or maximum two lines are going to be added in that program of singly linked list, and we will get a circular linked list. I mean, the insertion of the nodes in a singly linked list we have already seen in detail. In the same fashion, insertion in the circular linked list will be done. Let's see, in short, just a summary of what will be the insertion in a circular linked list before we read the code. Just assume for some time that we have already inserted some nodes in a circular linked list. It's always good to assume that we have such a circular linked list already, where every node is having next pointer which stores address of the next node, and next pointer of the last node where the last is pointing back to the first node, and first is pointing to the very first node. Now assume somebody asks you to insert one more node in this circular linked list. To keep ourselves comfortable, we will insert a node at the end of the list. So new node will always go at the end. That means we are going to make a call to malloc function, just as we did in singly linked list. We are going to allocate a new node and ask some pointer like temp to point to that newly allocated node. The newly allocated node will then store the value that we are interested in. And now comes the fun part. Now you see the next pointer of the last node. Check the cursor. Next pointer of the last node. This one. This next pointer, which was actually pointing to first, shouldn't point to first, but the next pointer of the last node should point to 40. What do you say? Because 40 is joining the list, isn't it? So that means we are going to execute a statement, last arrow next. Yes, everyone? Last arrow next means 30 is next, should be equal to temp. So last arrow next, check this, last arrow next should point wherever temp is pointing. You know that temp is pointing to 40. So last arrow next will also point. One more line that we will execute is temp arrow next. See the next pointer of the node where temp points. This temp arrow next should point wherever first is pointing, and first is pointing to 10. Node which stores 10. So temp arrow next will point to 10. So that's another line that we will have to write. Temp arrow next should be equal to first. Now one more line to end it. Now you see last pointer which I am encircling is pointing to 30. We don't want that now, isn't it? Who is the last node now? 40 is the last node because 40 is pointing back to 10. So we will change last and we will say last you should point wherever temp is pointing, and temp is pointing to 40. So one more line that will be written is last equal to temp. I hope you are understanding. Last equal to temp. So last pointer will discontinue to point to 30, but last pointer will now point wherever temp is pointing. And that's it. That is insertion. You see, after the insertion, we have got a new node 40. 40 is next is pointing back to first, that is 10. And 40 is genuinely the last node. You see, last pointer is pointing to 40. So simple, isn't it? So simple. Okay, let's repeat this very fast. Suppose we are inserting 50 now, a new value. We said we will always insert 50 at the end or any new node at the end. So allocate the space and ask temp to point to the new space. So 50 is stored in temp arrow data. Everybody knows that. Now you watch last arrow next. Last arrow, last arrow next should point wherever temp points. That means last arrow next will discontinue to point to first, but last arrow next is going to point wherever temp is pointing. And temp arrow next, observe this temp arrow, new nodes next will point wherever first is pointing. So temp arrow next will become equal to first. And one more change before we leave the function. Last should not point to 40. Last should point to the new node 50 because that's the last node now. So we will execute last equal to temp. So simple, isn't it? These set of statements have been written in the insert node function. But now you see the insert node function has got two pointers, two pointer to pointers. In the singly linked list program, we had this insert node function in which there was only one pointer passed because we were passing only address of first. But now we will have to pass address of first and address of last because two pointers, first and last, are to be manipulated always. Okay. So this is the summary of the circular linked list. Just to give you an idea that it's going to be very easy. I mean, if you have come across singly linked list very well, if you have watched that video thoroughly and practiced it, you must practice that particular program by writing it, drawing the diagrams, reading the statements. You won't find any difficulty in understanding circular linked list. So we start this program of circular linked list. Circular linked list program starts again by declaring node structure. You see, every node is going to contain integer data and a pointer to next, which can point to any node. Then we have insert node function, which will insert only one node at a time. Then we have display function. Display will display the entire circular linked list, all the data. Then we have delete node function, which will delete only one node which is asked for. So we will pass the value that we want to delete. Suppose we pass 20, then the node which stores 20 should get deleted. And finally, we have main. So let's start our discussion from main. In main, we have declared two pointers, first and last. In the singly linked list, I repeat, in the singly linked list, we had only first pointer. But now we have said that circular linked list will be maintained by using two pointers, first and last. So in the memory, there are two pointers, first and last. And remember, these two are node pointers. So first and last can point to any node. But look, we don't have any node made yet. Node will be made only after call to malloc. Hence, we make both first and last, observe, we make both first and last null. Now, if first is null and last is null, it means the list is absolutely empty. There is no nodes yet created, so first and last can't point anywhere. and now we call insert node function. Insert node is called by passing address of first and address of last. You know, pointers themselves have address. Maybe address of first is 500 and address of last is 600. Then we are literally passing address 500 and address 600. And we are passing the value that we want to add. The value that we want to insert is 10. Okay, so let's come to insert node function. In the insert node function, as you see, we have two pointer to pointers as the parameter. P receives address of first and Q receives address of last. So to repeat this, first, as you saw in main, first was null, and as you saw in main program had last also equal to null. But we assumed the address of first is 500 and last is 600. Now P is the pointer to pointer which literally stores address of first. Observe, address of first is 500. So P points to first. Similarly, Q is a pointer to pointer, second parameter, which will literally store 600. Observe, address of last is literally 600. So Q points to last. Now onwards, if I write asterisk P anywhere in the code, it is same as first. And asterisk Q is same as last. All right, I know that these are sheer repetitions. If you have come through singly linked list properly, if you have read that and practiced that properly, then this might be bit of irritative steps for you because you already know what is P and Q. I assume that. Okay, and X, the third parameter X is going to be 10. Let's read this. The function starts by declaring two pointers temp and A, which are node pointers. So in the memory, there is a pointer called temp, and remember temp is a node pointer, so it can point to any node, and A is also a node pointer. Both can point to any node. Now check the line, temp is equal to malloc. What are we doing is we are allocating size of one node in the memory. So somewhere in the memory, there will be one node allocated. This will be a node structure, and node structure can store data, and there is a pointer called next. But the allotment is going to be done at some address. Imagine that the address at which malloc has allocated the node is 1000, then temp points to that location 1000. Isn't it? Temp points to the node. So temp stores the address of newly allocated node. And it is our responsibility, you all know, to check whether malloc was successful or not. Malloc is unsuccessful if it was not able to allocate memory. If malloc is not able to allocate memory, then the temp will be null. Temp pointer is null. If temp is null, we will stop the program. We will print cannot allocate memory and we will exit the program. Yeah, there is no point in continuing the program when there is memory deficiency. But we will assume that this, if never becomes true, we have enough memory. Okay, so the node was allocated. And now we come to the next line. Temp arrow data means the data of the new node will become X, that is 10. So hence we have successfully stored the data 10. Now what? The next thing we ask is asterisk P equal to null? You can read this as if first is null, isn't it? Yes, and first is null. Observe the picture. The pointer first is really null. It is null, isn't it? Hence these two lines will run, which are read as, these two lines which I am marking are read as first equal to temp, last equal to temp. I hope you are getting it. First equal to temp means first will point to the same node where temp points, and last equal to temp means last will point to the same node where temp points. So first and last both point to the same node. Of course, they should point to the same node because we have only one node. If we have only one node in the list, then that first node is the first and that same node is the last also, isn't it? So first and last are no more null. They have been changed and they efficiently point to the very first node. So obviously after this else won't run. I hope you are reading the program sequentially. Else won't run. So else portion from brace open to brace close is skipped. But the line which I am now encircling runs temp arrow next equal to P. This is it. This is good, isn't it? You just see the statement that I am marking here. Temp arrow next equal to P, asterisk P. That means temp arrow next equal to first, isn't it? So trace it, trace it. Where is temp arrow next? Observe the cursor. Temp arrow, temp arrow next. This is the next we are talking about. Temp arrow next equal to first is written. That means temp arrow next, which is a pointer, should point to the same node where first is pointing. But by the way, first is pointing to that same node, that is 1000. So temp arrow next will point to the same node. Oh wow, look at the circular linked list. We have got only one node. So the nodes next should point to the same node circularly, isn't it? What will happen? What will happen when we get the second node? 20. Then next of 20 will point to 1000, isn't it? Next of 20 will point to 1000, and next over here, next of the first node will point to 20. But right now you observe there is only one node. So the next of that very first node should point to the same node in which it is stored. And congrats, we have finished with the insert function. We have finished with it, isn't it? After this line, temp arrow next equal to first, this is end of insert. And you all know when the insert function ends, lot of things are destroyed. Q is destroyed because it was local parameter of the function. The pointer to pointer was made when the function started. So we don't need this anymore. P is destroyed. It was also a local pointer, isn't it? And temp was surely temp and a were declared locally. Although we did not need a this time here, maybe we will need a next time. Who knows? Let's see. So all these pointers are deleted. Look at the circular linked list. Just check the circular. I'm just cleaning the slate. Okay. Check the circular linked list. We have only one node. The node is first and the same node is last. Just observe it. And the next pointer of the first node is pointing to the first node itself. All right. Let me clean a few more things. As my habit goes, I just keep marking the statements. This is my method of reading the programs. Let it become as messy as possible. But as long as we understand the things from scratch, it sounds good, isn't it? Okay. And by the way, we programmers are really not accustomed to neatness. As far as my experience is concerned, the more messy the things, more happier we are. Anyway, okay. So now assume that this insert node function is called second time from main. Here we are. The insert node function will be called second time, and second time we are again passing address of first and address of last, and the value we want to insert is 20. So let's come back. Let's come to insert node function. Insert node will again have a pointer P, which is a pointer to pointer, which will receive address of first, point to first, pointer to pointer called Q, which will receive address of last and point to last. From now onwards, asterisk P is same as first and asterisk Q is same as last. And the value of X that we are inserting is 20. Okay. So in the function, there are two pointers temp and a declared, which can point to any node. I'm doubtful actually, this a is not needed in the function. Anyway, let's see later. If it's not needed, forget it. Okay, temp is a pointer which can point to any node. You know the meaning of this line. Temp points to newly allocated node, isn't it? Temp points to a node, so the allocation will be done for the node. Node can store data and has a pointer called next. Maybe the allotment is done at address 2000, then temp will store 2000 and temp points to the node. The next line checks for the failure of malloc. We assume that there is no failure and node was allocated. The next line, which I am marking, is temp arrow data should become 20. So the new node is going to store 20. And now the next if is going to check is first equal to null, because asterisk p is same as first. And you notice the picture, first is not null because first is pointing to 1000, address 1000, because that's the address of the first node. So as first is not null, what do you know? What does our program discover? Our program discovers that the new node that we are inserting is not the very first node. The new node that we are inserting is some consecutive node, isn't it? So a special treatment should be given as far as that consecutive node is concerned. We come to else, and now in the else we execute just two lines. Observe asterisk q arrow next. How will you read that? Yes, yes, last arrow next, isn't it? Because asterisk q is same as last. Last arrow next equal to temp. So observe last arrow next. Trace it with the cursor. Last arrow next. This is the next we are talking about. Last arrow next should become equal to temp means it should point wherever temp points, and temp points to 2000. So last arrow next points to the new node. So what we know is this next which was pointing back to the same node, this continues to point here. But the next pointer of 10, next pointer of the node 10 points to the node which stores 20. I hope you got it enough, isn't it? Now, one more line, you check, I am marking it here. Follow the cursor, one more line. Last equal to temp. Observe that, last equal to temp, isn't it? What does that say, last equal to temp? Last should point wherever temp points. Now you know that temp is pointing to the new node. So last will also point to new node. So here we go. Last, oh, oops, where is the cursor? Sorry, wait a minute. Yeah. Last will not point to the existing node, but last points wherever temp points. So last points to the latest node, isn't it? Latest node, the new node. And that's it. We have finished with the else. And now when we come across this line, which I am marking, before we end the function, we say temp arrow next equal to first. Asterisk p means first. So observe temp arrow next. This next of 20 we are talking about equal to first. That means temp arrow next should point to exactly the same node where first is pointing, and first is pointing to the 1000. That is node stored at 1000. That's it. Congratulations. We have finished the execution of insert function for the second time, and lot of cleaning work will be done. Temp will be erased. It was a local pointer. A was not at all used. By mistake, I declared A in my function, and all these local pointer to pointers will be deleted. They were declared as a local parameter of the function. And look at this. When we are back in main, we are having first and last regularly pointing to first and last nodes, and first node is genuinely pointing to second, and second being the last node points back to first. Excellent, isn't it? Now tell me the summary. Don't read the entire insert node function. Tell me the summary. What if we want to insert one more node? 30. So temp is equal to malloc, isn't it? Temp should point to the newly allocated node. Then temp arrow data should become equal to 30, the data that we have passed. Also, last arrow next, last arrow next should point wherever temp is pointing. Observe the cursor, isn't it? Last arrow next should point wherever temp is pointing. So last arrow next, which was pointing back, which was actually pointing back to first node, will not point to first node anymore. But last arrow next, that is 20 is next, is going to point to 30. Now one more line. Temp arrow next. Observe, temp arrow next means this next of 30 should become equal to first. So temp arrow next will point to the same node where first is pointing. And one more line to go. Last equal to temp. Observe, last cannot point to 20 anymore, but last should point to the same node where temp points. That's it. Then we have got the third node, and third node is the last node, so it is pointing back to the first node. I repeat, dear students, you can learn this efficiently only by reading this again and again and drawing these diagrams just as your teacher was doing. Trust me, I learned the linked list, binary tree, graphs, all these data structures by reading and not by typing. You have to become readers of this program, and you have to imagine what happens in the memory due to each line. And I trust me, I bet on it that you will never forget the coding or singly linked list or circular linked list or any data structure. Thank you very much.